In this video, we will be developing the code for 2D elastic collision. As far as this generalized code is, this is from the video revision state. So we'll be changing this one itself, and the function we developed to solve for three unknown variables, non-linear equation. Three unknowns. Okay. I can go for coordinate. I have to see that one from here. Okay. Let's see. First of all, we have to make start 0 dt. We have to keep as close as possible so that position vector of two collides, and we are gonna give two particles some like size to it by keeping a range. When two position vector collides, they like they don't have to be exact, they have to be in some range. That's how we are gonna give size to a particle. So count is 50, number of particle, let's say 2. Let's bound it in this plane. Okay, bounds, px, by, and bz. Number of particles, pv, position vector x, y, z. Okay, this is randomly generated. We don't have to actually randomly generate. We have to generate it by it. So we don't need this one. We'll generate it by ourselves. Two particles. So we are gonna keep it in xy plane, z as 0. You can get anything z as 0 for particles. So for one particle, let's keep it at x is equal to 0, and second particle let's keep it at 10, and y xy plane let's keep y same for now. Let's keep it 10 10. Let's see how it looks. Initial velocity, final velocity, we will see it later on. Okay, zeroing with this one. Okay, I have to see also this dash and cosine of this one. We'll see later on. First of all, we will see how is our initialization state. Here is our two particles in xy plane. One particle, two particles, they will collide, and we have to just code for that part. Okay. Yes. So PV U. So one I have to keep 0, and another one I have to keep something else, but it depends upon the code I have written. The state code, how to use it. It has been made and U unity. So I'm gonna go for I is gonna want to count and state position vector v all rows and 1. Let's see how is this state x all rows and okay, this I could understand U. So here is U. The way I have to use it, there will be no acceleration, so we can keep acceleration as 0. Keep it as 0, and keep this one will be also 0. A is 0, so ones of size x is 0. The thing we need is this part. So I have done one mistake, right, like this in different rows. Now it will be in different rows because I'm going for different rows like 0 20, so it should be like in rows. Particles will be separated in rows. Okay, x y z position vector. Let's see again what's the position vector. PV 0 10 x y and z. Okay, this is good. So u has to be ones of yep. So this thing has to go. I don't think this one would be needed. I have to go for one of size x, so I need it to be like first having velocity of, let's keep it as 5, and the other one having velocity of 0 starting. Direction cosines, okay, like this, making 0 0 and 1. The thing is, it depends on this one, direction cosine 1. Okay, you can actually do u dot, no, this has to change, like really it has to change. It is constant, it doesn't matter here. dd, it has to be one-on-one multiplication. dd, let's hope it works out well. Okay, so you would be like 2, so I need to do 2 direction cosines in there. And for second one also, you can go for 0 0 1. This will be second, for second particle. This is the first particle direction cosine, this is the second particle. So here I don't need this one, I need to go for dot product of each row, each element, so I don't need to go for this part. I don't even need this part. Acceleration part is not even needed, so you can keep it anything, it doesn't matter. This one is not needed, so why do you include it in there? Okay, just don't include acceleration. Okay, and I'm not going beyond bounds. If minimum of x is going to beyond bounds, no, these things is not needed. I'm not going beyond bounds. Okay, position vector is always 3. U is gonna change like this. No, it's not gonna be constant. Ti, let's say Ti will be like that. It doesn't matter. Okay, for now, like let's hope it's working good. Let's run the code. Anything else I want to here? No. I don't even need DCA and acceleration. Let's keep it like there. It won't be needed. I won't remove it. Okay, let's start. Okay, change the folder. You gotta be getting me wrong folder. Wait a second, Control C. I have to change this. I have to go for revision 1, collision 1, generalized code. I will paste it here. I'm gonna undo this one because I need that one exactly the way I have done it. Save it. New state. Collision 2 is there. Collision is there. Okay, let's continue anyway. So there's an error in state. It's saying unable performance because the size of the 2 by 2 all rows. And go for like x, y, and z. So again, okay, x data must be a vector. Okay, understand what's happening in there. X started changing. So let's see the x value. What is it like? So it's like 0 10. It shouldn't be like that. Why is it like that? I done something wrong. UDCV. Let's see how is DCV. Okay, I had to do like this one, but there will be like 2 rows and 2 columns. X. Okay, I have to see everything here. Wait a second. Let's see how it's written. Position vector 1. I had to go for U. And I had to go for DCV. Let's see what's wrong. So the thing is, position vector is 0 10. Okay, 2x 5 0. That's okay. Direction cosine is the thing that's wrong. Okay, I understand. So it's actually in x direction, lost in x direction. So it should be now it's only the course of alpha 1, all rows, comma 1. Yep. It should be all rows, comma 2, all rows, comma 3. Now I think it will work. Let's see x after this. X. Now it's going in upward direction. Wow. Because DCV cos of, yep, I know exactly, because cos, we are using cos of theta, so it should be opposite of what I am gonna do. And so with where is it? This is here. So cos d, I will use cos of 0, cos of with x and y is 0, and cos t with zx is gonna make 90-degree position vector. It is gonna go this way, so it's gonna make a 19 here also. With x is going along x direction, so it will have anything here in this is at rest, so this will play for it. You can actually keep it 90 also. Let's see. Yep, now it's moving nicely. Okay, I can increase the number of time steps. Now decrease the difference between two, and I can go for count like 100 so that they actually do collide. Wait a second, maybe I need more than that one. 200 number of iterations, 200. Okay, let's keep it as 250. So for starters, we're going to keep it 0.1 and going to keep it 50. Yep, let's keep it like this. For starters, this is going to be good. Okay, now we're adding a code for collision now. This thing, we'll just see how it is written. Okay, let's put a state in there. Let's put it here if, so like position vector, we had just go inside the position vector of one particle with another particle. So I would say if position vector 1, let's keep one particle, we won't give it any size or range to it. We'll say if position vector all rows comma 1 is greater than equivalent to rows comma second, let's give it as 0.5 minus 0.5 and put it in, and the same thing if position vector all rows comma 1 is less than equal to plus this one, this is range like position vector of second minus 0.5, and both like it means that it has a size of 1. So let's for starters put it actually display collide. Let's see if it's colliding or not, and we're gonna use a function of collision 2D later on. First of all, let's do this thing. Let's run it. Yep, it's colliding. So it's colliding, okay. Yep. So we are gonna need to change p1, p2 dash, theta dash. So out is the thing we need. Control C, we're gonna put it here. Control V, out, and pushing the two things that will change is DCV and U. Of course, U is going to change. So U is equal to out Let's see. Out is like out one is v1, v2. Yep, out one, two. Let's run this much for starters. Okay, okay, something is wrong. Let's see later on because I haven't given coordinate yet. Okay, I can get it. So you change and that changes DCV. So DCV is actually equivalent to this thing. Okay, cos of 0, 0. This is it. X, Y, Z, X, Y, Z. So here, okay, cos out of third. Theta 1 and theta 2, and it is with respect to x-axis only. I haven't gone anything like y-axis, so here is out 4, out 4. So this is good. Now the coordinate, we have to just give a coordinate to it. Coordinate is like this thing. So coordinate, control T, it's M1, so I have to go for mass matrix. So I need mass matrix M. V1 and V2, I already know it. It's U1, and this is U2. Okay, theta 1. Theta 1 is actually theta 1 is DCV. Theta 1 is like this part. Okay, it's like first row comma first column. And the same thing here, like, wait a second, first row comma, no, second row comma first column. Where did this ti come from? Okay, but it's like cos t here, it is cos inverse of d. So a cos d, like I will say a cos d of 90 wouldn't be the thing. Cos of like 0, it's 90. Okay, that's the thing I need. This one. So if I actually have put it cos of d of 30, like I will show a cos of d of 0, it will be 0. That's what we are doing here. A cos d here is we need like this. Same thing goes for here, a cos of d. Okay, theta. Wait a second, what was the thing? Theta 1, theta 2 dash, and you have to give this angle. Okay, you have to give this is given theta. You can give it here, given. You can write it given. No, let's write it theta 2 dash. It's not great that much, so we need these two things. Control C, and we're gonna put it right here. We're gonna create a mass matrix now. Mass matrix of two bodies is like keep it as 5, 5. Okay, let's hope it works out well. Let's play this out now. Okay, theta 2 dash. Okay, I haven't even theta 2 dash yet. Theta 2 dash, let's give it at bottom 30 degrees. Yep, it's colliding now. What's wrong? M1, okay, yep. M1 and M2, what is M1 and M2? I've write it as M1 like this, M2 like this. Now something is working well. Something is, so it's not changing the direction. Okay, why is it not changing the direction? Out 3 and I, this thing is not. Let me check one thing. What is the value given here? With respect to x, so x has to be minus, something has to be minus out there. Let me check it out. It's taking time to actually solve that equation. Okay. I have put out without actually. Okay, wait a second. I have to suppress this thing. It's going beyond that thing. Minus. Okay, one is minus, one is positive, minus, and positive. So that cos doesn't have any meaning. So cos of negative is actually positive. So the thing is, last time I had changed. Cos should not change. B should change. Okay, that is it. Cos of it want I have to just make u change somehow. Okay, that would mean I had to go for maybe 2 or 3 here. Let's see. Going in opposite direction. Okay. Okay. Let me see the answer. That is good. That's working nicely. But the thing is, this answer is actually. So I had to just go for the negative is 30 degree, 30 degree, 90. Okay, if it's 90, it has to be like. Okay, this is also good. Control C, Control V, minus. Okay, I can go for 90 minus like this one. 90 minus this. 90 minus out of 4, and this is not changing. Output to y is output to 3.35. Okay, u second particle is not moving. I think it's, is it moving? U is here needed, and this one I'm not. Whatever u is, I'm gonna give it back, but whatever dcv is, I'm not giving it back. So I have to go for dcv. Okay, comma dcv. Still, why is u not like that one? Keep it closed. Keep this one open. I need to see u. Why is it not actually the thing? Let me keep this one also like this. Okay, run it now. Yep, now it's good. You can see it gets multiplied at 30. 30 and 30. That's cool. In this direction, it's actually about the answer now. How you are going to make it go depends upon which answer you're going to choose, because this equation, when solving for these 3 values, it has 4 values. You have to choose one of the thing. Let's choose first one. Okay, let me go for choose. Choose is equal to 1. Let me put here, there's wrong spelling. Control C. Let me see the answer for different things. Okay, this time I'm going to choose the first answer. How it's going to move. Oh, it's going to go like this. Okay, this is cool. Okay, now I'm going to go for, okay, this, let me put this closed. Let's not see this one. Control save this. I think this is done. I just have to change this one and this one. Now go for the second answer. How will it behave? Same way. I can go for like minus positive. Third answer. Same way. I only the fourth one. Or every answer is same. Okay. So cos of theta, actually cos of theta is positive, it's gonna that sign that thing. Cos of theta we're doing, that would be always the same. Okay, that is the thing that's happening, that's why it's same. Choose 444 here. So this is it, like every answer is same then, but actually the cos is different. But the thing we're going for direction cosine, so cos of theta, that doesn't matter. So there is only one change. Sometimes the particle one is moving like this in positive direction, not going back, and sometimes it's going back. You can see, like in two, let's see in two, it's moving going back, particle two, but in one, it's moving with it. Let's see. Okay, yeah, it's going with it. So that is the thing, because it's happening because cos of theta positive. So I have reduced answer 2 for now. So this is it for this video.